Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. Crane. Okay. As usual, we first come to its statement. The light from a certain galaxy is red-shifted so that the wavelength of one of its characteristic spectral lines is doubled. Assuming the validity of Hubble's law, calculate the distance to this galaxy. Okay, we have to find out the distance d as appearing in Hubble's law. Okay, as usual, before starting its solution in a formal manner, we will have to go through a few snapshots. Not enough snapshots. One, two snapshots. Three snapshots. Okay, three or four snapshots before proceeding to its solution in a formal manner. Students, according to relativistic Doppler shift, lambda dash over lambda is equal to 1 plus v over c over 1 minus v over c under root. This alternatively becomes equal to 1 plus v over c over 1 minus v square over c square under root, equation number 1, where v represents the relative velocity between the source of the light and the observer. Here lambda dash is the wavelength we measure on earth and lambda is the wavelength emitted by the moving star or galaxy in its own rest frame. Okay, so dear students, in this expression, which is basically a modification of relativistic Doppler shift, all things have been explained. Okay, expression has been described and it has also been described what is lambda dash in this expression, what is lambda in this expression, what is v in this expression, and c is the speed of light. Okay, now we move to next snapshot. Okay, no, yet not next snapshot. We are using the above snapshot with the condition, using the condition which is given in the statement that double. Okay, this condition that the light from a certain galaxy is red shifted so that the wavelength of one of its characteristic spectral lines is doubled. It means lambda dash over lambda is equal to 2 using this condition of doubleness. Okay, using lambda dash over lambda equal to 2 in equation number 1. This equation number 1. Okay, here we are using 2 in this place. Okay, lambda dash over lambda, here we will use 2 and then we will solve. Okay, using lambda dash over lambda equal to 2 in equation number 1, we get 2 equal to 1 plus v over c over 1 minus v over c under root, whole under root. Okay, this implies that we can take square on both sides. If we take square on both sides, then 2 will become 4 and under root on right hand side will vanish or disappear. Okay, so our expression will become 4 equal to 1 plus v over c over 1 minus v over c. From here, if we shift this denominator on other side of equality, then it will be multiplied with 4, and we will get 4 minus 4v over c equal to 1 plus v over c. Okay, here a numerator on right hand side is still as it is existing. We have shifted denominator on other side of the equality, and by doing so this denominator has also become a numerator on other side of equality, and it has been multiplied with 4, and hence we have got this expression. From here we will simplify it. So this 1 will be subtracted from 4 and we will get 3. Similarly, this v over c will also be subtracted from this minus 4v over c, and hence it will become minus 5v over c. Okay, so our expression after simplification will become 3 minus 5 v over c equal to 0. This implies that v over c equal to 3 over 5 equal to 0.6. Okay, if we divide 3 by 5, then we get 0.6, and hence our v over c, that is to say this is called speed parameter. This quantity is also sometimes denoted by beta. Okay, speed parameter. V over c is equal to 0.6, or in other words we can also write it as v equal to 0.6 c. Okay, anyhow, now dear students, we define parsec and then light year. Okay, parsec. The parsec, symbol PC, is a unit of length used to measure the large distances to astronomical objects outside the solar system, approximately equal to 3.26 light year. Now we will define light year. Actually, light year means light, that is c speed of light, that is to say 2.998 or 3.0 into 10 raised to the power 8 meter per second. Okay, this is light, and here 365 days, one leap every fourth year leap year, so 365.25 into 24 hours into 60 minutes into 60 seconds. When we will multiply both these, then second will be cancelled with second and our answer will become in meter, and then we will convert that meter into kilometer. Okay, so anyhow, we define light year. A light year, alternatively spelled light year, ly, and sometimes we also denote it by cy, that c for light and y for year. Okay, a light year, alternatively spelled light year, ly, is a unit of length used to express astronomical distances and is equal to exactly 9460730472580.8 kilometer. Okay, so here once again we explain how this number comes. This number comes 365.25, or approximately, suppose we do not consider a leap year, then 365 into 24 into 60 into 60 into 3.0 into 10 raised to the power 8. Okay, so all these multiplications will make a figure about close to this. Okay, and in that multiplication second will be cancelled with second, and meter will be converted into kilometer, and hence our answer will be near to this. Okay, now dear students, we move forward. Now we define Hubble's law and Hubble parameter. Okay, the proportionality between the speed of the galaxy v and its distance d is known as Hubble's law, that is v equal to h naught d. Okay, here v is the speed of galaxy and d is the distance and h naught is Hubble's parameter. Okay, the proportionality constant h naught is known as the Hubble parameter h naught is equal to 72 kilometer per second divided by megaparsec. Okay, dear students, we have explained parsec. We have defined parsec, and megaparsec means 10 raised to the power 6 parsec. Okay, the uncertainty in this value is on the order of plus minus 4%. Okay, now using Hubble's law v equal to h naught d, this implies that in place of v we have used 0.60 c, which we have calculated in earlier part of this solution. Okay, is equal to h naught this and d we have to find out. Okay, h naught d, from here 0.60 into, in place of c we have used value of speed of light, that is to say 3 into 10 raised to the power 8 meter per second. Okay, sometimes in place of 3 we use 2.998. Okay, no difference between 2.998 or 3.00. Okay, is equal to 72,000 meter per second. Here we have converted kilometer into meter, so 72 has become 72,000 meter per second divided by megaparsec. As per definition of parsec, which says which says 3.26 light years. Okay, 1 parsec is equal to 3.26 light years. 3.26 light years. 3.26. If we divide it by this, it becomes parsec. Here we are dealing with megaparsec, so 10 raised to the power 6 will also become here. Okay, and d we have yet to determine d. In the next step we have kept d on one side. By keeping d on one side, this figure in the denominator will be multiplied with this, and similarly this figure will be divided on this. Or in other words, we can simplify it in several other ways. For example, we can write it 72 divided by 3260. Okay, because these three zeros will reduce this 10 raised to the power 6 to 10 raised to the power 3, and when 10 raised to the power 3 multiplied with this, it will become 3260. So we can write 72 divided by 3260. Okay, anyhow, this is just a simplification, and hence our d becomes equal to 0.00815 light year, cy. We can also write it as ly, light year. It is a matter of discretion whether we denote light year by cy or ly. Okay, next, this is just a rearrangement of this quantity. So our answer D becomes equal to 8.15 into 10 raised to the power 3 light year. Okay, actually, dear students, because we have shifted decimal 3 stages ahead, we have shifted decimal 3 stages ahead, so 8.15 into 10 raised to the power 3 students, I think perhaps this is 10 raised to the power minus 3. Actually, dear students, perhaps during simplification, mm, you can also uh, check this manually. Okay. Mm, because here some minor mistake appears, because here d, when we convert it in 8.15 light year, then it should be multiplied with 10 raised to the power minus 3, but it is 10 raised to the power plus 3. So perhaps there some minor mistake has remained. Okay, remaining all things 100% quite right. Process of solving this problem is 100% correct, and answer is also correct, except this, that this 10 raised to the power 3 is doubtful whether it is plus or minus. Okay, you should check this. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.